Greetings to Doctor. I'm Prisha Murgia. So today I'm going to present about the app that we create to solve the numerical analysis problem. The app that we created is a root finding app. We use this app to find the root for Newton-Raphson or second method. This app will be very useful to the students who are studying numerical methods or to the professionals who are looking for a quick tool. Newton-Raphson method, or also known as Newton's method, is a root-finding algorithm which produces successively better approximations to the root of real-valued function. For example, the root of function fx is equals to x to the power of 2 minus 4 is x is equals to 2 or x equals to negative 2. Because when you plug in those values of x, the function equals to 0. The idea behind the Newton-Raphson method is to start with an initial guess for one of these roots and use calculus to refine that guess until it gets closer and closer to the true root. This is the coding for the Newton-Raphson method. So as you can see, we use button push function. This function is used to let the user to put any kind of function. After the user run the coding, they will get the calculator app that we created. This app takes 4 edit test fields, with 3 of them would be editable for enter the function, initial guess, and epsilon, whereas one would be a non-editable holding the value of approximate root. The example question x to the power of 6 minus x minus 1 with an initial guess of x naught is equals to 1.5 and epsilon set up to 0.0001. When we solve this question in traditional method, sometimes there will be an error in the calculation. So to avoid such things, we created Newton's method calculator. By using our app, we can solve the question easily and also will get an accurate answer.
We will proceed with the part 2. The second method is a numerical method for finding roots of a function. The second method uses the slope of a line between 2 points on the function to approximate the derivative. To use the second method, you will start by choosing two initial guesses, which is x1 and x2, that are reasonably close to the true root. Then you will calculate the value of the function fx1 and fx2 at these 2 points. Using the 2 points, you will estimate the slope of the function between them by computing the slope of the line passing through the 2 points. This is the coding for second method. As you can see, we use the push button function. This function is to let the user to put any kind of function. In the coding, we will declare the function, the two initial guesses, which is x1 and x2, and the epsilon. The user can edit this three coding or enter the function. After the user run the coding, they will get the second method calculator. Next, we will calculate this example using by normal calculating and our second method calculator. For example, if the function is 230x power of 4 plus 18x power of 3 plus 9x power of 2 minus 221x plus 9 with an initial guess of x naught is negative 1 and x1 equal to 0 and the epsilon set to 0.0001. So the answer will be is 0.0408. If we can see, if we using normal calculating, we will get many decimal places that may cause error. By using our app, we just need to enter the function and the value of x1, x2, and the epsilon. And we will get the result for the final iteration is 5 and the approximate root is 0.0408. If we use our app, the answer will be very simple and accurate more than we use the normal calculating. As we can see in the part 1 and part 2, we can conclude that the rate of conversion for Newton-Raphson method is very fast than the second method, and both of them have no guarantee of conversion. And that's all from me. Thank you.